going to give a description about orbitals. Orbitals were the next development in describing and predicting behavior of electrons in atoms. And basically, an orbital is a location in an atom where an electron has a probability of residing. Now, I'm going to take the simple case. Let's say we have a hydrogen atom. A hydrogen atom contains one proton and one electron. The proton is in the center of the atom in the nucleus, and then surrounding it is the single electron. The name of the space that this electron can be has a probability of being found is called a 1s orbital. So at any given moment inside this sphere, and the 1s orbital has a spherical shape. It's shaped like a ball with a defined radius around the nucleus. So at any given moment, that electron might be here, at another time it might be here. Electrons are moving rapidly, and we could put a dot, if we took snapshots in time very quickly of the location of the electron. Now sometimes it could be outside of it, but generally it's going to be clustered. The locations that we would find over time is inside this 1s orbital. So orbitals, they have an associated size and shape. There's also an energy level associated with orbitals. It's worth pointing out that the energy associated with an electron residing in an orbital is a function of its distance from the nucleus. Coulomb's law describes electrostatic energy associated between two charged particles. And Coulomb's law is there's K is a constant, Q1 is the charge of one thing, and for the hydrogen atom, that could be the proton in the nucleus. The second charged species is our electron. R is the distance between the two charged particles. And because the proton has a positive charge, electron has a negative charge, the sign of this energy is negative, and that's associated with attraction. But what's also important is to note that radius, the distance between the particles, is in the denominator. So the larger the distance between the nucleus and the electron is, the smaller E will be, the energy of attraction. So a large distance between the charged particles means a decrease in the energy of attraction. When R is small, the energy of attraction is great. And that means it's stable. And another way of looking at this is to say that the closer an electron is to, to some extent, the closer an electron is to the nucleus, the more stable it is in the atom. The lowest in energy, the lower in energy, and the more stable. So there are other s orbitals, but they have different energy levels associated with them. So 1s, that is n, the quantum number, similar to the Bohr orbits. And that is the principal quantum number, and that is generally associated with rows in the periodic table loosely. There's a pattern that will show you. And then S is a sub-level. Within n equals 1. The higher you get in values of n 1, 2, 3, 4, 5, 6, 7, the more, to some level, the more number of sub-levels there are. It's worth pointing out that on the second row of the periodic table, we start seeing n equals 2. And n equals the 2s orbital is also spherical in shape, and that's because it's an S. But it's larger. It occupies a bigger volume. And that's because it's in the next energy level up from 1. 2 is greater than 1, so the 2s orbital will be larger than the 1s orbital, and the energy associated with electrons residing within this orbital is going to be higher than the energy associated with the electrons in the 1s orbital.